Hey everyone, just a real quick review of doing that stem and leaf plot, as well as the quartiles, and just kind of making sense of this again. So here I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20 numbers. Alright, those 20 numbers I want to organize down here. I need to have 20 entries when I'm done. The way I have this organized is on the left I have a stem, and on the right I'm going to have a leaf. The leaf can only ever be one digit. Alright, so these are all two-digit numbers, which makes it easy. This digit will go on the stem, this digit will go on the leaf. So when I'm going through here, all of them are good, and I'm going to start at 85 and say, well, here's the 85. I don't have any 70s. I do have two 60s and a 65. I don't have any 50s. I've got two 40s. I've got two 30s. I do have a 45 there. I almost missed that one. Two 30s. Here's a 25 and three 20s. Looks like four 15s and two 10s. And then this one. Notice it didn't have a number over here, so it's a 0, 5. So that's how the stem and leaf plot works. And I'm just going to look. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. There's my 20 for the stem and leaf plot. Alright, so remember this is similar to a histogram because if I turn this on, whoa, that was weird. If I group this all together and then turn it on its side, I now suddenly have kind of a histogram. I can see that this histogram looks like it is skewed to the right. All right. So the question is going to be whether or not these are outliers. So we are going to measure that by using something that is called the interquartile range. And we figured that out before, and we'll just kind of review that again. In order to find the interquartile range, I first had to start with finding the median. So the median in 20 numbers, I said, was going to be 20 plus 1 divided by 2, which ends up being 10.5. That 0.5 tells me it's halfway between the 10th and the 11th number. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Here's halfway between 10 and 11, so the median is 22.5. Alright, now when I have that split up, you'll notice I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 numbers over here. Alright, so 10 plus 1 divided by 5 is going to be 5.5. So halfway after the fifth number, here is where that first quartile is at 15. And 1, 2, 3, 4, 5 and a half over here, I've got 42.5. Alright, that was what we used to draw what we called a box plot, where we divided it up into the quartiles, and then we sometimes call it a box and whiskers plot because the whiskers went down kind of like this, so showing how far it went. So what we are going to be doing is figuring out the outliers. Now, the outliers, we can use kind of a rule of thumb. It's not something that you should use. You should not use this as a definite. You should always still look at the data, but I want to see this and say like, could that really be an outlier? So I'm going to use 1.5 times the inner quartile range. All right, so the inner quartile range means what's the difference between 42.5, which is quartile 3, and 15. So that's because we have 4 quartiles. And here's the 2 outside quartiles. Here's the 2 inside quartiles. You know, they're the ones that are inside the box too. So what I need to figure out, first of all, is what's the range. So 42.5 minus 15, that's what's going to end up giving me my 27.5. All right, that's the inner quartile range. All right, if I want to figure out what this number is, I'm going to take 1.5 times the 27.5, plug that in the calculator, and I get 41.25. All right, so 41.25. That's the range. So what that means is, if I end up with something that ends up being further outside of that, then that's an outlier. So what I'm going to do is I'm going to take that 41.25 and I'm basically going to add it and subtract it. I want to see what's the biggest and smallest number I can get to over here. So I'll start with the one on the left. It's easier. So if I take and add 41.25 here, I end up with 84.75. Or excuse me, 83.75. I can add. 83.75, that's right here somewhere. That tells me that this 85 is too big. So this is an outlier. When I go the other way, I'm going to start at this 15 and I'm going to go 41.25 to the left. I'm going to subtract it again. That's going to put me way over here at negative 26.25. So these numbers are definitely not outliers because I still have a lot of room. So basically, when we're taking a look at this, here's the set of data that we had before. We had something like the quartiles were 5. This was 10 to 30. And then I had this number way up here, 60. I want to know, is that 60, is that an outlier? Or where do the outliers start? So we subtract the two numbers for the interquartile range. So 1.5 times 30 minus 10. So I really have 1.5 times 20, and I end up having 30. So I can add 30 going this way. That puts me right at 60, and I can subtract 30 going this way, so negative 20, which tells me that this is not an outlier because it fits inside of there. Again, that's not a hard, fast rule, but that is a general guideline for finding out whether or not something is an outlier by using the median and the interquartile range. All right, so keep that in mind. Our next lesson, we're going to start going into standard deviation.